Hello to everyone. This is Mirza Tamovik and you are watching my YouTube channel. So welcome back with our first video, which is totally about the A levels. So in this video we are going to learn about the basic quantities which are very useful in chemistry regarding measurements. Like there are four basic characters including mass, volume, time and temperature. So I am going to tell you why these four properties are so important for you and why we have to learn basic of these four properties. And if you have not subscribed my channel, so I'm requesting to you all kindly subscribe my channel, and so shall we start our video and you don't miss any of my video, because these are so important and so interesting videos that you must have to watch and learn. And I will tell you the complete ABC, or you will be the master of chemistry after watching my videos. So before starting my videos, before starting my lectures, I'm going to tell you that there are four physical quantities which are measured by its unit. For example, mass, which has unit kilogram, volume has a unit cm cube, and time has unit second, minutes and hours, and temperature has a famous unit like centigrade, and other is Kelvin, and sometimes we use Fahrenheit. So by starting from mass, so mass of a cubic centimeter of water are the melting point of water. Okay, now this definition is sold in 1795. Now international prototype kilogram held by a national metrology lab around the world. Okay, it was a standard mass which is used right now to measuring the different masses in the world. So that is the base. And now what is the base? Mass of 1 cubic centimeter of water at melting point of water. But now the international phenotype kilogram held by the international metrology lab around the world is the basic unit that we have used right now for the measuring of mass. Metrology means the scientists who study about the earth and the other physics. Now volume is derived from the length. Such a unit is meter. In the old definition is that the length was meter was 1/1 million of the distance from the Earth's equator to the North Pole, the sea level. Now the length of a path traveled by the light in a vacuum at during time interval of 1/299792458 of a second. Okay, the old definition is saying that it is 1 over around about 10 million of the distance from the Earth's equator. But now the length of the path traveled by the light in a vacuum during a time interval of 1/299792458 of a second is termed as 1 meter. So that is the basic definition of meter. And now we are saying that 1 meter divided by something is called the speed, and which unit is mass. Now before 1000 CE until 1960, a second was 1/86,400 for man solar day, and from 1960 to 1962, a second was a 1/86400 multiplied by 365.25 of Earth's orbit around the Sun in 90s. And in 1967 to now, a second is the duration of 91926317770 periods of radiation, corresponding to the transitions between the two hyperfine levels of the ground state of cesium-133 atom. Cesium, you all know, is a radioactive element. So it is the latest definition about second. And as we know that there are so many complications in this duration, and we have changed this definition. Now the correct definition is the second is the duration of 91926317770 periods of radiation. So that's the basic definition of second. So moving to the next. So our next portion, our next quantity, next unit is temperature. So temperature's SI unit was Kelvin, but in secondary school we are still using centigrade. Now Kelvin is defined as a fraction of 1 over 273 of the thermodynamic temperature of the triple point of water. And what is the triple point of water? Which is roundabout or exactly 0.01 degrees Celsius or 32.0158 Fahrenheit. Okay. Okay, now comes to mass. Mass have different units. The famous unit is kilogram. So 1 kilogram is equal to 1000 gram. There are basically two instruments, beam balance and electronic vanish, which is used to measure the mass of an object. The accurate one was the beam balance and the other one is electronic balance. So both can measure the mass up to an accurate value. Sometimes we use that there was a jar or glass covered over the mass meter, so it measures up to 4 decimal or 5 to 6 decimal. So what the question is there, what is the purpose of the mini glass enclosure around the weighing pan? Why we put on that? So the basic reason is that to avoid any disturbance, to avoid any external record, to avoid any external thing which can affect our mass. So that's the simple reason that we all tries to cover the weighing plan with a glass, and we tried our best. So who's the most efficient one is one that can measure up to microgram of a mass of an object. I mean to 5 to 6 decimal of a quantity. So that's the main thing that I discuss with you. The second thing is volume whose SI unit is cubic meter, and other common units are dm cube, cm cube, liter and 1 milliliter. Now we are coming with the relation. 1 dm cube is equal to 1000 cm cube and 1 liter will be equal to 1000 milliliter. Okay, so we have 1000 of milliliter in 1 liter. So the measuring instrument that we use for measure the volume is measuring cylinder, whose approximately measure 1 cm cube to 100 cm cube. Okay, now here I am showing you the basic instruments. It is a measuring glass, measuring scale. We have many marginal lines, so we can easily measure the volume of that liquid through these lines accurately. But I will tell you one thing, after that you have to learn while measuring the liquid of any object. So here we have another tube which is used to measure the very small amount of water or any other liquid. It can be used as well as a dropper. So it says it can measure the size, so the volume up to 20 ml of a liquid. Now we have a grit which have also many scales, and we can calculate the volume of liquid through these scales, through the margins. Easily we can measure the volume of a liquid and up to 50 ml or maybe up to 100 ml. It's depending on the size of the grit. So the main thing that I wanted to discuss is about the level of any liquid. We have mainly two types of liquid that we will discuss later. So you should have to keep your eye in just exact in front of your level while measuring the volume of a liquid. So it is a simple flask, measuring flask, which also has graduations marginal lines over it, and we can easily measure the size of the volume of a liquid through that. Okay, I hope you all will understand what I am saying, and you all will have to learn these instruments and their names. I repeat, as we have, firstly we have a measuring cylinder, now we have a measuring flask, and then the burette, and sometimes we use a pipette for a very small amount of a liquid. For the measurement of a very small amount of a liquid, we mostly use pipette, and in flask we use up to 300, 400, 250, and up to 500 ml of a liquid is mainly used. So that's the end of this instrument. Come back to our topic. So we have burette, okay, then we have volumetric flask, then we have syringe can also be used to measure the very small amount of liquid, for example cc, 5 cc, 3 cc, 10 cc syringe. It has another unit for volume, which is cc, centimeter cubic, okay, small. So we have a syringe, and which is filled with a liquid. So it is also has a marginal line graduations on over its surface, over its glass. So we can easily calculate this value. If we apply the pressure from the other end, the liquid will definitely move. Okay, now the next important thing, that how to take a reading of a liquid. So read at the bottom of the meniscus. What is the meniscus? Except of mercury, other than mercury, all liquid that you have to read the bottom of the meniscus. Meniscus means the curved line over the liquid surface. The curved line over the meniscus, over the liquid surface, is called meniscus, and for mercury it is upward, and for the other liquids it's definitely always to be down. You can see where that we have two different liquids. For one liquid, the level will be near about 20.0 centimeter. For the mercury, it is above the marginal line, which is definitely more than that of 20. So okay, so always keep in mind that for mercury the meniscus is negative, and for other liquids the meniscus is lower, and for mercury the meniscus is higher, or at the upper level. And you can see the difference between the levels of these two liquids. Although both liquids have same volume, but the meniscus of both liquids is totally opposite to each other. Okay, let's how will you calculate the reading of this liquid. So now we are saying that the meniscus is about exact meeting with the line. If I can zoom for you, so it is exactly 23.5 cm cube of that liquid. So that's how you will take the reading. And 23.5. now how can you calculate the reading with the help of a burette? So the same method that we used for the previous one, now the same liquid has 23.650 cm cube of that liquid. Okay, please keep in mind that your eye is in front of your liquid level. Okay, I say seconds, and we have hours, minute, and 1 hour is equal to 60 minutes, and 60 minutes is equal to 3600 seconds. Now Kelvin is equal to centigrade plus 273 digits. Okay, alcohol in glass and mercury in glass. We have two thermometers, which one have alcohol and the other one has mercury. Both these liquids can be used? Okay, the question is that isn't alcohol colorless, and why is the liquid red? Isn't alcohol colorless, and why is that liquid red? So that's the question for you, that why alcohol is colorless. Okay, in thermometer we definitely use some liquid which must have a color. Okay, for example, let's use a thermometer and we have to calculate the reading of this thermometer. So I can zoom this picture for you. So it's about 29.5 degrees Celsius, around about you can say 30. Okay, why collect gases? Allow us to determine the progress and the rate of a reaction. Okay, why collect gases during a reaction? So this is allow us to determine the progress and the reaction. For example, we have calcium carbonate and hydrochloric acid. When both these chemicals react, they produce calcium chloride, carbon dioxide, and water. So during this reaction, the release of carbon dioxide will allow us to determine the progress and the rate of that reaction. So by measuring the volume of the escaping gas, we can calculate the rate of a reaction. Okay, method of collection depends upon density, compressed air, and the solubility in the water. There are two methods of collection: density, compressed air, and solubility. Solubility you can define as the number of grams of a solute dissolved in the 100 gram of that solution to make this solution saturated. This is the concept about solubility. I repeat, number of grams of solute dissolved in 100 grams of solvent to make it saturated. This is the concept of solubility. And density, you all know that the mass per unit volume. Okay, I am repeating, the mass per unit volume is termed as density. So both of these characters can help us in collection. For example, we have chlorine and water, and both of these reactions are allowed to react. And now we have hydrogen. Okay, displacement of water, downward delivery, upward delivery, and using a gas storage for gases which are insoluble in water like hydrogen, oxygen, carbon dioxide. And when we use downward delivery for gases which are denser than air like coloring, and when we use upward delivery for gases which are less dense than air like ammonia and hydrogen, and when we using a gas syringe when there is a need to maintain the rate of evolution of gas. I repeat, downward delivery is used for the gases which are denser than air, and upward delivery is used for the gases which are denser than air like ammonia and hydrogen. So these denser gases can move upward and easily removed. And left, this is for the less dense gases. Okay, the first one, displacement of water, is used for gases which are insoluble in water. We have intake for the for these gases, and these gases are easily insoluble in these water are not soluble in water like insoluble in water, sorry, hydrogen, oxygen, and carbon dioxide. So these gases are insoluble in water. So the last one is using a gas syringe when there is a no need to maintain the rate of evolution of gas. Then we used this method. So watch this picture and try to learn then how we when we use display method, and then when we use downward delivery, when we use upward delivery, and when we using a gas syringe. Okay, and I hope you have learned and you have the concept about the delivery tube positions when we use syringe, when we use downward delivery, when we use an upward delivery. Gas syringe is obviously used and there is a need to monitor the rate of evolution of gas. Indirectly we are wanted to calculate the rate of reaction, as we have known that by calculating the evolution of gas rate we can calculate the rate of reaction. Okay, next is how to collect a dry sample of a gas. So press the gas through a drying agent, then concentrated sulfuric acid, which is used to dry the acidic gases or gases which do not react with acid. As we know that sulfuric acid is a dehydrating agent. So if we have to dry a gas means this gas has some moisture, so we need some demoisturizing agent, so we need some dehydrating agent. So we definitely use sulfuric acid. Sample of a gas may be acidic, alkaline, or neutral. So the easiest message is past that drying agent, which is definitely your sulfuric acid. So if your gas is alkaline, neutral, or acidic, so you can use sulfuric acid. We can see the apparatus. So there is a gas inlet and this gas outlet, and we have concentrated sulfuric acid in this flask. Okay, how to collect a dry sample of a gas? Press the gas through as a drying agent. This is a second method, and we have using a second dehydrating agent, which is calcium oxide. It also have the ability to collect, to absorb water from the surrounding. The third thing that we use is the fused calcium chloride. It is used for the dry neutral gases only. Sulfuric acid is used for the neutral for alkaline gases. Calcium is used for the both, and the fused calcium chloride is used for the dry neutral gases like hydrogen. Then how to collect a dry gas of example? Pass the gas through a drying agent, calcium oxide, that is used to dry alkaline gases, and fused calcium chloride is used for the dry, and sulfuric acid is used to dry acidic gases. Okay, there are, now we are saying that there is something that has contained fused calcium chloride. Fused calcium chloride, as I know that, as I tell you that it is a solid that has the ability to absorb moisture from the surrounding. So you can see it is start moisture. Okay, properties of common gas is ammonia, which has a formula of NH3, is colorless, less denser, and it is extremely soluble in water. We are comparing gas, its formula, its color, its density, and its solubility in water. Okay, slightly ammonia is extremely soluble, carbon dioxide is slightly soluble, chlorine is soluble, hydrogen insoluble, hydrogen chloride is very soluble, oxygen is slightly soluble, and carbon monoxide is soluble. उसके बाद then next, measuring change in mass during a reaction. Measuring change in mass during a reaction. For example, we have calcium carbonate, hydrochloric acid, and when it reacts it forms calcium chloride, water, and carbon dioxide. Obviously carbon dioxide is leaving this mixture, so definitely the mass of the reactant will be less than the mass of product. Okay, we have a graph, we have a table where we are discussing the time, the mass reading, and the change in the mass. For first 0 second there is notching, so we draw a graph where about time and the mass ratio. So we have seen that the graph reached to a constant value. The graph reached a constant value. The constant value means that our reaction is completed, our all reactant is finished, is used, and our carbon dioxide is completely out of our mixer, so it's mean our reaction attain a stable position. So it's mean one or the both of the reaction has been used up. The smooth line is the indication for the end of reaction. Okay, what's the cotton plug for? Definitely, if we put a cotton plug at the end of the flux, it's mean we don't want carbon dioxide to leave that mixture. We want the carbon dioxide or any other gas which is produced is to remain as such there. For example, we this follow this reaction, and as a result which carbon dioxide is released, it definitely tries to escape out. And if we want to hold this carbon dioxide in the same flux, then we definitely will cover this gas. As we know that carbon dioxide will definitely tries to rise up, and we will try our best to put cotton plugs on that end of the flux and try our best to hold carbon dioxide for some time, because we do not want carbon dioxide to leave this mixer. So I hope that I tried my best for all of you, and if you have any query, any question, you can simply ask it through my comment section. Oh, thank you so much.